Continuing the summary from sections 3.3 and 3.4. Here's what we learned in the last exciting episode. That's using the critical numbers to find the relative extrema. So now we are at this point. Where are we? Section 3.4, concavity and points of inflection. Now, this is exactly like what we just did, except everything we do is going to be using the second derivative now for concavity and points of inflection. So we have to find the possible points of inflection first, and the possible points of inflection are where the second derivative equals 0. After we find that, we're going to do everything that we just did, except with the second derivative. So here we go. Here's the steps we're going to follow. And here we go. So now I'm just concerned with the second derivative. So first derivative was this, and then we factored it to so it was easier to find where this equals 0. When you take the second derivative, you don't want to take the derivative of the factored part because that would make you use a product rule. So we're going to get rid of that. It's much easier, as you can see, just to take the second derivative of the unsimplified first derivative. That's negative 6x plus 6. So now we have to find the possible points of inflection, which is where this equals 0. You can obviously see it's going to equal 0 at 1, I believe. But when they get more complicated, you want to get into the habit of factoring, like I just did, and then find out where each factor equals 0. And obviously negative 6 doesn't equal 0, so you don't have to worry about that. And this would be x equals 1. So that's your possible point of inflection. So now you set up a chart, just like the last problem. But instead of using the critical numbers, you use the possible points of inflection. So here we go. My only possible point of inflection was 1. I'm going to go negative infinity to 1 for the first interval and 1 to infinity for the second interval. Next, we're going to pick a test number each interval and determine the second derivative. And we just care, again, if it's positive or negative. So in the first interval, I'm going to pick 0, and I'm going to figure out what the second derivative is at 0. The second interval, I'm going to pick any number in that interval. I'm going to pick 1,000 just because it's in the interval. So you look at this second derivative, and if you plug in 0, we're doing the first one now. If you plug in 0, you get a negative 6 times a negative 1. So a negative times a negative, which is positive. That means we're concave up. When you do the second interval, if you put 1,000 into it, you get a negative 6 times, obviously, a positive number, which turns out to be negative, which means concave down. So that tells us everything we need to know. Going back to this summary, oops, I don't know where it went. If the second derivative goes from positive to negative, which it did, the graph goes from concave up to concave down, and we have a point of inflection. So we know we have a point of inflection now right here. at x equals 1. So we have concave up on negative infinity to 1, concave down on 1 to infinity, and now we have a point of inflection at 1 comma. Now to find the y value, it's just like, again, the mins and maxes. You must use the original function, which I'm going to pull down right here. If you plug in 1 to this original function, you will get negative 1 cubed is 1, plus 3 times 1 minus 2, or 0. So the point of inflection here is 1 comma 0. So that's the second part of that summary sheet. I'm going to end this video here, and then I'm going to do the rest of this summary sheet in video number 3.